Welcome everyone to another episode of Hyperbolic Orbits. And to introduce our guest today, I want to go back to one of the most famous quotes by Dr. Carl Sagan when he said that the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. Today, our guest is someone who has chosen a field of study which is very, very complex, and it is astrophysics. His name is Kshitij Pandey. He comes from the beautiful state of Rajasthan in India. If you're not familiar with India, and if you've seen very beautiful pictures of forts and palaces and deserts and all things beautiful, and chances are that you've seen pictures of Rajasthan. And Kshitij had studied physics in his college days in Jaipur, which is the capital of Rajasthan. And during his undergrad, he did something really wonderful. He participated in international competition where he were competing against hundreds of students worldwide. And he also won a silver medal during that competition. And he also was so interested in dark matter since his early days that he presented his research at Stanford Linear Accelerator Center once. Kshitij then moved on to do his master's and further studies in cosmology and astrophysics. And today we are going to hear the story of Kshitij's educational journey and what he's currently doing right now. Welcome, Kshitij. Very, very happy. It's such a pleasure to have you here with us today.
Thank you so much for having me, and thank you so much for this lovely introduction. I'm flattered for that. And yeah, I really like the name of the hyperbolic trajectory. I really like the name, the way it
Thank
has
you.
the scientific essence in it.
Yeah, thank you. Yeah, it also it's it attracts a lot of space geeks, which I myself am accused of. So So I would really, I when I first got to know about you, I was really happy with the way your educational trajectory is like, you know. So could you tell us a little bit about how it started, how you got into physics, and how come astrophysics?
Sure. So the only thing that I retained from my childhood was that the urge of asking question, why is these things happening, right? So from the very starting only, I was curious about these scientific events and why these things happens, what scientists actually do. So I think it was that time only when I decided that I want to pursue a career in science. But when I think when I was in eighth grade, I met a geek and he was reading Brief History of Time, and he actually told me to read that, and I was really inspired by that book. And that time I decided that maybe I should go for astrophysics and cosmology, not very clear during that time. So anyway, I finished my 12th, and then I wanted to do a BSc honors in physics. I went for that. During that time I got some good exposure. I was living near some good places, so I came across with Dr. Rakesh Tibrewala, who was he did his PhD from TFR, and he was working in various astrophysics field. So I approached him and I said that I want to work in the field of dark matter. He said, yeah, you can work. And then we did some literature work. During that time also, I went to IIT Kharagpur, where I presented my work on neutrinos. So neutrinos, even though I have done my studies in astrophysics, but my love is mainly for the particle physics. So I lie in between astroparticle physics. Those who have seen Big Bang Theory, it is the intersection of Raj Kutrapali and Sheldon Cooper, right? So that is a field of my expertise and field of my interest. So during my bachelor's time, I actually did all these things, and I graduated during the lockdown. And uh, I took 1 year off because I didn't want to pursue my master during the lockdown, so I continued with a job. And then I took admission in masters. The experience was great because during that time I get to introduce with, first of all, Kaushik Bhattacharya. He was professor at IIT Kanpur. So for 1 year I did my master's project under him. We working again on scalar field dark matter. And then there was something very interesting happening. A news was around that we have detected very high energetic cosmic rays, and I was really interested about those things. And during that time, some of my colleagues were working on how these particles accelerate near the black holes. One alternate model is naked singularity, and how these particles are accelerated there. So they were actually also looking for someone who has some expertise in particle physics and interest in that. And I thought that it was a good opportunity to use my interest and use my expertise in that field. So we collaborated. It resulted in a paper, and it was under Professor Pankaj Joshi. Professor Pankaj Joshi is a very renowned scientist for giving JMN naked singularity model. So basically, we used his model only. He did that work with like Manav Panena from South Africa and Ramesh Narayan from Harvard. So this was a very famous paper which was also featured in the Scientific American. So based on that model, we did that, and it was a good work. So far, my journey from my early childhood to this was my simple trajectory. If I have to summarize this in a very small.
Well, it is simple. I don't know, but definitely very interesting. I like how you said that it's astroparticle physics that you're interested in. And what I really want to ask is, okay, when a student starts understanding that I want to go into basics, fundamental sciences, I want to build a career in research, what I really always am very curious to know from people like you is that how does this research interest develop in case for your case, did it start by you met these wonderful professors and researchers and you understood what they are working on and then you said, okay, this is what I'm interested in? Or was it that, okay, I think I have certain inclination towards certain fields, like you said, particle physics is what interests me. So you then moved forward with it and found the experts in this field to do your research. Which one was yours?
Okay, so there are two layers, and when I'm talking about it, I'm talking for a very general case. First, in your childhood, when you actually decide that you want to become a scientist, why you want to become a scientist? Because these things are very interested. But first, you have to be introduced by those things, right? And there comes the science communicator. I was privileged enough that I was living in the era where shows like Cosmos were there. Carl Sagan, I was very familiar with the books of Carl Sagan. I read the book of Stephen Hawking. So it is because of those books, those great science communicator, that I got familiar with these subjects. And then I decided that I am interested with this, I'm interested with that. There was time I thought that I should pursue cosmology. Even in my master's, for a long time I studied cosmology as well. So this is something, see, what happens is that if we see historically, if we talk about Newton was not just a physicist. In fact, physics was not developed during that time. He was normally a philosopher who did work in physics, mathematics, and a lot of things. So I believe that the true essence of an explorer is to explore things irrespective of the subject. But then you decide that in which area you actually want to go forward to, because at the end of the day, we have a very small lifetime. We can do a little of the work only, and we have to specialize in something. So I thought that maybe space is the something that I am very much interested in. When I was in my 12th grade and then I moved to my first years of a bachelor's, I realized that I'm also very much interested how we all are made up of. What are these particles that we all are made up of? How these particles are created? And it was that time when I also started to get interested in particle physics. So here comes how this intersection happens. I went to Rakesh Tibrewala and I said that I want to do research with you. I didn't say that I want to research on that topic. He was very open. He just told me, explore whatever topic you want to do. I go across a lot of articles. I read a lot of paper because I was in my bachelor, so many of them I was not able to understand. I went across a lot of popular scientific videos from the great scientists, and I came across the idea that there is a field of dark matter where you can consider dark matter as a particle known as WIMP, weakly interactive massive particle, and you can consider that as a dark matter. So my main idea here is that once you get, first of all, you get interested by all these science communicators, and that is the initial phase of your life. There you decide that, okay, I want to become a scientist, I want to become an engineer, I want to become, let's say, XYZ. But once you start to get deeper into things, you have to be introduced by the possibilities, right? There are many scientists historically who were working initially on something, then got inspired because they were not familiar with those ideas, and once they get to know about the ideas, they decided their trajectory to be in that way. So once you start to get deeper into the things, the best thing I think is to reach out with the people and to connect with science communicators. Science communicators connection is very important because it is the duty of science communicators to cater with all the different things happening in the world of science, to explain you things. They cannot be expert in all of those fields, but they can at least have ideas about what is the cutting edge research going on in those fields. So I think that is a good way to know what are the some good interesting way. In fact, during my master, I told you that there was a big event. It was one of the science communicator only that I came across the idea that this event has happened. So my paper is on that field now. So this is very important.
Thank you. I think that is very some very important points you said is first that get inspired by people. And today, like you said, we are very lucky to live in this era. It's not Newton's or Galileo's times when, to a large extent, they were working on their own and they were probably, scientists were probably exchanging letters among themselves. We don't have, I mean, no matter how much we can say things about social media, but it has opened up a whole world for us. And for anyone, I mean, nobody can actually say right now that I don't know what to do. In fact, we have too much to do right now. So, what would you say that for someone, for example, I'm not even saying just a school student or a undergrad student, even for senior students in higher studies, sometimes some students do feel a sort of hesitation to reach out to, experts in their field. It's a common thing. You get a little scared. And I get this question a lot, that how did you reach out to this person and get this research job? So, what is your preferred way, or if you for the first time, if you have to talk to a professor, how do you present yourself?
Okay, so basically there are two ways of reaching out to a professor. First, you meet them physically, and maybe during a conference or they come for a guest lecture, then you talk to them. And oftentimes, this is the best way to reach out to a professor, because when you get a personal touch, you actually are able to express about yourself, and it's more likely that they will accept like positively. Now, we have to keep this in mind that these professors who are working in the area of research, once they were also a student, they were looking for the guidance, and they actually know the importance of guidance. They actually know the passion about those things. It's just they are very familiar with the field now, and they get a lot of students. So it is not possible for them to respond each and every mail. The like hard reality of being in India is that there are a lot of students who are constantly mailing professors all the times, and like it's not possible for professors to reply mail all the time. In fact, sometimes they have to create a specific spam filtration for those things. So that's actually a very troublesome thing. But anyway, if you want to reach out to a professor, first of all, figure out why you want to reach out to a professor. Let's say you have interest in some field and you decided to pursue your career in that. The first thing should be to see who are the prominent figure working in that field. Are they working recently in that field? Once you know that this person is working in that field, you go across his or her profile, you see what have they done, you go through the paper. Now the thing is, well, like, to be honest, chances are you will not understand 90% of the paper, and that's not your motivation. Your motivation is to understand what is the nature of their work, and that is going to decide your trajectory. How are you going to write the mail? One thing that students do a lot of time is that they decide a template for the mail, and then they change the key information, for example, name, their designation, their research interest, and everything remains same. And if you think about it, like, if you have to mail hundreds of professor, who has the time to write a personalized mail for each of them? Tailored mail becomes very hectic, but that's the hard reality. You have to spend time on that, because if you don't, it's like you will not respond, you will not get to hear anything. My personal experience is that professors from foreign universities reply like more often than Indian universities. In fact, I have got, when I was in my bachelor's, I used to write a lot of mail. I used to spam professors with mails, and I used to get a lot of reply from Stanford, sometimes Harvard, and some of the renowned institutes. But getting a reply from IIT was very tough. It was like tougher than getting response from Stanford and all those things. But anyway, I would advise to design a tailored mail for each and every professor, and show them why you are curious. Just don't go to a very templatized thing that ever since I was a child, I was interested by this, I want to proceed my career in this, and so on. Just like tell them who you are exactly, because they are going to get hundreds of mail about that. If you stand out because you are actually narrating a true story, that gives you a better chance to stand out, and that actually works.
I absolutely agree 100% with what you said, because this idea of creating a template, unfortunately, a lot of people advise students to do that, but it does not work. I mean, I mean, I'm not even a senior professor, but if I get 20 LinkedIn messages with the same template, I don't feel like responding because I don't want your formal idea of what you think communication is. I want to know why you are messaging me, why particularly you thought that you should be reaching out to me. And like you said, I can imagine professors, senior professors get thousands of emails, and imagine their plight if they have to go through the same message. And now that we have AI word generators that keeps repeating. So I think, like you said, the best way, which always works, is to write first, find out what they are doing. And if you really like it, then please write an email saying what you want to learn from them. That's a wonderful thing you said. Another nice point that you raised earlier is that the importance of science communication. And that is also something I know you're very interested in right now. You are training yourself, you're doing very well in that. So I want to hear from you that you got inspired by science communicators. I got to, like I always say, I'm not a huge science fiction fan, but the real life science heroes are my actual, heroes. So the way the person, a space person, when they communicate what they work on, that really resonates with young kids. So what is your aim with science communication right now, and why do you think it's so important right now at this age? I'm asking this question because there are plenty of science communicators, and it's important to be very authentic and right in what you're saying. So that's why I wanted to ask you this.
Thank you for pointing out that question. So we all always say that we are living in the age of information, and I always reply with the same answer that we are living in the age of misinformation, because it's very easy to get misinformed. During my master, I used to take classes to some students for the astronomy. I used to give lectures on astronomy to school student, and toughest part was not to communicating the real science. It was to let them aware that whatever they have seen on YouTube, random videos about aliens and all those things, they are not right. So most of the time, my time was spent to let them know that how can they know the source is authentic or not, whether they should trust the person who is just randomly saying things or not, whether you should trust it or not. So 30 to 40% time my time used to go there only. It was that time I realized that misinformation is actually a very big problem right now, because there are a lot of things. There are a lot of WhatsApp universities things. You get to say NASA has said this, NASA has said there will be a solar storm that will destroy the entire internet for, let's say, months. There are always news like that. And in that kind of scenario, you might ask that whom can you trust? So why I went to the field of science communication? So there are two reasons for that. One is very straightforward, because I was very much into public speaking. I always like to communicate with people. I always like to engage with people, and that was a hobby of mine. So science communication is one thing that actually blended two hobbies of mine. So it was the first reason I want to do science communication, because of that. Second is the because of the academia. So what happens is that while I was doing research, I get to realize that I'm interested with some of the most fundamental questions. And the thing is that all these things, these mathematical constructs are sometimes not very viable. The things that I'm actually working on might not be the true case scenarios. Now, I'm not speaking for all of the research areas, but some of the specific parts. So I decided that maybe I should keep a hold on my research for now. Let's focus on science communication. It's not that I'm avoiding research forever, but right now I want to focus on science communication. So I decided to let's pursue a career in science communication only, to do a lot of things. And yes, the biggest part is how to be authentic. First of all, see whom you are listening to. Best thing is if they have some good recognition in that field or good qualification in that field, that's a green signal. But I would not say that a person without any designation cannot do anything. They can also. It's just they always have to come up with an authentic source. If they are presenting you authentic source, if their reasoning are sounding, and they are talking about good stuff, they are actually making you think rationally, then they are authentic. So I used to follow these science communicators only. I was inspired by them, Vanitasium, and there are so many people. The biggest one is Carl Sagan, obviously. Carl Sagan is my science communication inspiration, and I was very happy when you quoted his quote in the starting. So Carl Sagan is is the biggest figure for me in science communication. So I think that's pretty much it. I want to do science communication because I want to take some rest from the academia. There are some downside which I don't want to talk right now. So that's why I switched to science communication.
That's quite a wonderful reasoning that you have, and especially like you said, it's important to know who you're listening to, especially in the influencer age. And I also totally agree that you don't need to have all sorts of the so-called established educational degrees to always talk about science, but it's just that it helps. And if you don't have that kind of degree, at least go do a little bit of research and make sure the information that you're passing on in is not wrong. So now that that thank you for sharing this. The next thing I want to know is again astrophysics. Coming back to that, because for the first question is that there are astrophysics is a big subject. It's not like some people say study of the universe, study of stars, study of this, that, but it actually has a lot of sub disciplines within it. So, you being from this field, I want to ask you, could you shed some light on what are these divisions within astrophysics?
Yeah, sure. Wonderful question, and this is one of the question that I get a lot on my Instagram and as well as on my LinkedIn. So each and every field is a very vast field. Astrophysics itself. So what exactly is astrophysics? I would first clarify that so that I can go deeper into the answer. Astrophysics is the study of physical processes that are happening in the universe, that are physical in nature. What is physical in nature? A comet is revolving around? No, that is not physical in nature. We want to study the physics of it. It means when a star is collapsing, so something like tremendous and exciting is happening there. Or let's say a black hole, how a black hole is ejecting so much matter, how actually things are working around a black hole. And during the birth of the universe, how dark matter was created, how dark matter is actually working, what is dark energy. Now dark matter and dark energy is a field where cosmology intersect with the astrophysics. So there's a lot of intersection. See, with the particle physics, when you go deeper into the particle sector, you get intersection with particle physics. When you go to a very broad range, you get intersection with cosmology. But talking about very specific fields, first there is compact object study, that is black hole study. Now black hole study itself is a very large study. There are so many models of the black hole, there are so many things to study about black holes that you can spend an entire career on that, and you will not be able to study each and every model of it, right? So there are some people who specializes in study the magnetic field around a black hole. There are some people who specializes in studying the orbits around the black hole, S2 star, precision, and all those things. So there are a lot of things to study around black hole. That is one example. For the dark matter, because most of my life I've spent working on dark matter only, there are more than 300 models of the black hole. Even the best expert in the world will not have the entire picture of the dark matter. It is chances that whatever they are working on, that might be the true shadow of the reality, but we never know whether on which way. It is always a bet, right? Whether whatever model you're picking, whatever theory you're going with, it's always a bet whether it's going to be right or not. So then there is dark matter, there's dark energy, there is how the stars are collapsed, how neutron stars are formed. Then there is gravitational wave. Gravitational wave have gained so much attention in the past decade. Gravitational waves are there. A lot of there is neutrino astronomy and neutrino astrophysics. So basically astronomy is something that how we observe things, but rather than light, if you use neutrinos for that, it's going to be known as neutrino astronomy. And trust me, I have not said half of the names in the subdivision, and that they too are divided into so many things because it's not possible. But these are some of the main fields in which works are going on. There are high energy cosmic rays. That was my dissertation topic during my master's. So high energy cosmic rays, as I said, black holes and all those things. So a lot of things. Now the biggest question is that how you decide in which field you want to work with, right? You want to work on, and that's the biggest problem that students face. I have seen this a lot. Even my classmates were very confused. I remember during one semester they realized that this is not something I want to work on. Then they are changing their field in the second semester, and that's a good thing about being a student. You get the privilege of doing that. But once you become established professor, once you are getting your position based on that field only, although you have the freedom to do that, but still uh, you somehow become a bit restrictive unless you are very open minded about other fields as well. So best way to explore is to read about literature reviews in each and every field. There are, I think, some literature reviews on the various fields of the black hole, of the development of the black hole. And you know what's the best way to know in which field you want to work on? To study the history of science. I personally believe that's the best way, because when you actually study the throughout development of the science and engineering and all those things, you then realize that okay, if this is how these fields are coming from, so if I'm interested in this, I will go in this and that. I mean, this process helps a lot. So history of science is very important and a good way to understand various fields about the astrophysics, and not just astrophysics, anything.
This is brilliant what you said. First of all, when a student starts, it's always like, I want to go into space. Then it's figuring out, like in my case, it was figuring out science or engineering. Once you have chosen science, now what to do in that? And like you said, you have not even named half of the disciplines that are there within it. And I'm so happy that you clarified so much, because there are too many options, which means there are too many possibilities. But choosing a field, yes, as a student, you get to experiment a lot, because every field requires different set of skills, and it's not possible for one single person to be good at everything that they're free to choose whatever they want to. And since you talked about Big Bang Theory, I just suddenly recall this. I remember Sheldon Cooper trying to switch from string theory to dark matter at one phase. So yes, and all of this requires a lot of understanding of mathematics as well, if I'm not wrong. A lot of good foundation in mathematics is also very important. And the other thing is, once you've chosen, let's say, a field to study in, a very narrowed down field of astrophysics, let's say you've chosen, let's say you realize after a point that this might not be, like after you've become an established researcher, that this might not have a lot of future. I'm not saying dead end, but it might not, this theory might not be as promising as they thought it used to be. The other side of it is also true. Like, a lot of people did not even think gravitational wave theory would be so, they would be able to prove it, and it happened. So if that kind of a juncture comes, and so is it very demotivating to think that, okay, I'm not on the right path and it's time for me to switch? Or is it right to stay on that path and realize that it's science, and no matter what you do, sometimes you're always progressing, you're always moving forward?
Yes, yes. So this brings me to the incident when in 2012 the Higgs boson was discovered in the Large Hadron Collider. So what happened, that when the Higgs boson was discovered, for sure, there were so many scientists crying during that time, because many of them spent 40 years of their life disproving the presence of Higgs boson. So just imagine one single experiment quickly disproved all of their life works. So what I want to establish here is that there's always a possibility that whatever you're working on might not work. And this happens a lot in science, right? There's always one true answer and many false answers. So a true explorer should have the essence to go to chase the reality. But obviously we are humans, it's not possible exactly. So there is one theoretical physicist that I follow, Samira Hossain Pender. She has written a wonderful book, Particle Physics in Crisis. So she was saying that in particle physics, certain things have reached to a dead end, because we are doing things because we are attached to the ideas. There are some professors who are renowned, who are very renowned, and they have spent years of their life on some topics. Now they don't want to switch to an alternate theory because they have emotional connection to that. It would feel like that they have wasted all of their life. And trust me, who would want to feel like that they have wasted their entire life on something wrong? No one wants to feel like that. So there's one kind of bias in academia when we talk about that happens especially in the field of fundamental physics, because you don't get to prove a lot of things in fundamental physics. So the thing that happened with the Sheldon was actually the correct thing. A lot of scientists are actually going through this feeling that how do they know that whether they are wasting their life or not? This brings me to the answer that scientists are not chasing the answer exactly. They are chasing the pleasure of finding the answer. But again, it doesn't mean that we don't want to know the answer. So there has to be a balance. If you are enjoying that field, let's say someone is enjoying doing string theory, there is no problem with that. They just have to come with the in agreement with the fact that they might not be able to prove that thing, or there is a chance that that is not the true reality of the nature. So even that also, if someone realizes that they have reached to the dead end and they feel like that they want to pursue the true reality, I think it's never too late. Quoting David Bohm, who was a very famous physicist, he later started to work on philosophy of mind, how consciousness work, and all these things. There was a famous scientist Fermi who actually worked on how life works. So these are the explorers actually. They are not just the scientists; they are explorers. They want to know the reality. It doesn't matter what field they are working on. And I think a true explorer will always find a way.
It's brilliantly said. And I think it also relates to what you mentioned earlier about the history of science, that studying the course of how scientists develop. I'm forgetting her name, Dr. Ghosh. I think she's a very famous physicist who
Yeah, I know
always,
Dr. Ghosh.
yes, she always says that, what interested me in school, it was how, not how to get a result how of a numerical. It was how a scientist came up with that derivation. Like in
Hmm.
school, at least in India, where we studied, it's like we are made to do these derivations in the exams. I don't know why we memorize those derivations, because you only develop the aptitude for science when you understand how it has been derived and not what the correct answer is. That also relates to what you said. Thank you. And if I go a little more deep into your interest in dark matter, so what exactly was your research area, or what you want to do in the future if you want to go back to dark
Sure.
matter?
So I told you, right, that sometimes people come to an agreement that whatever they're working on, it might not be the true picture of reality. That actually happened with me as well. So I told you during my third year, I was working in the field of weakly interactive massive particle, and there are more than 300 models of the dark matter. Scientists have been trying for decades to prove these models right, but they are not finding any evidence. So I decided maybe I should move on, and even if I want to pursue dark matter, maybe I should see an alternative approach. And the model that I was working on is right now the most famous model. Some of the most prominent scientists in that field are working on those models, and that is known as scalar field dark matter. So anyone who is familiar with normal physics, they must be knowing about Bose-Einstein condensate. Basically, it's one of the state of the matter in which you reach to a critical temperature. So some particle who are showing bosonic nature, you don't have to know what are bosonic nature, but if they have this bosonic nature and they reach to a critical temperature, they start to show a very weird kind of a very weird kind of behavior. So this was actually my research area, that maybe this Bose-Einstein kind of behavior is shown by the dark matter. Now, this seems to be very crazy, like everything we are surrounded by dark matter and critical temperature. Generally, people argue over this, that critical temperature are always very low. So if you go through the mathematics, critical temperature are low if you have high mass. So because there is a mass correlation, there is an inversely proportion with the mass. But if you have very tiny mass, then critical temperature can be very high and universe can sustain that. So my majority of my work was first of all to study this nature of the dark matter using condensed matter physics and quantum mechanics, that how this non-linear Schrodinger equation evolve. Then second part of my research was to study the cosmology a bit and to understand how this dark matter was evolved. So I did a literature where we saw that the earlier model, the most successful model of the dark matter, lambda CDM model, which has started to fail now, it is showing the same result as CDM model, but it is also giving the positive result for the failures of the CDM model. So this was my research during my third year in my master's. But in my fourth year, I told you that I switched. And this is also a very interesting thing. So what happened is that we have Large Hadron Collider on Earth, and they produce the energy in order of 10 to the power 14 electron volt, which is very, very high. 10 to the power 14 is very high energy. Somehow, we are getting some kind of cosmic rays which have the energies in the order of 10 to the power 21 or 10 to the power 22 electron volt. On Earth, with so many billions of dollars, we are able to create 10 to the power 14 electron volt. And not all the cosmic rays have this high energy. That's why when first cosmic rays were discovered, they were named as cosmic rays, then high energy cosmic rays, Then they found even higher energy cosmic, so very high energy cosmic rays, and now we have reached to the name ultra high energy cosmic rays. Maybe after some time we get energy scale of 10 to the power 26, they will name ultra max high energy cosmic rays. So anyway, coming back to the topic. So this is a big question, that how these cosmic rays are being generated, because there is no known process in the universe that can create such a high energetic particle. So my work was, as I said, my supervisor gave the alternative model of the black hole, which is naked singularity. The simple difference is that there is no presence of event horizon. When you go through the derivation, you find there is no presence of event horizon. So what that allowed us is to accelerate those particles near the singularity. And there we found that with the collision of the particle at that scale, at that high energy, we can actually receive some particles with that energy order, even higher. So that was my master's work.
That sounds very interesting. Thank you for explaining this in so much detail. And what I'm really understanding is it's been so wonderful talking to you. And I'm so happy that you've chosen up science communication as one of your place of work. And because you not only have a very good affinity towards physics, understanding the fundamentals, you also are communicating it so well. So I'm sure a lot of not just students, but anyone who's interested in fundamental sciences on what you're talking are going to benefit a lot from you. So I want to say that please become an active science communicator. We need authentic people in this field. But before I let you go today, I have another curiosity.
Yeah, sure.
I love reading books. I force my friends to read, literally force my friends to read books. And in our mastermind community, I've announced that we'll start a book club, because I think anybody who's interested in space or in general, people should be reading a lot of good books. So if I had to ask you, what are your top three favorite science books? What would you say?
Okay, so first of all, mostly I have read the academics books, but there are some certain books which are non-academic in nature and I like. First one is The Cosmos by Carl Sagan. Second, although many parts of the brief history of time have been proven wrong, but that created an approach inside me. So brief history of time will be there. And then there is book by Sabina Hossain Fender, Particle Physics in Crisis. Now that book is very important for me, is because that actually allowed me to question the things. By the way, I want to just share, because we are talking about books and all. So when Galileo actually presented his result of heliocentric model, and during that time that model was not very well established, people were not accepting, church was not accepting that model. So when Galileo presented that idea in his book, 75% of his book was based on convincing people that your knowledge can change, the ideas that we know can be wrong. Just imagine that his main concern was not people will accept it or not. His main concern that we have to train people that they can unlearn things to know about new things. And then 25% about like the arguments for the heliocentric model, and many of them were wrong also. But anyway, I personally like that book because he was actually focusing on the rationality of human mind. And that is one thing that I would emphasize everyone to go through. That's a very wonderful book. Don't read that book to know about the heliocentric model, but to know how human mind actually works and how we can use reasoning and logic to prove something.
Thank you. Yes, when we think about Galileo or Copernicus in that sense, I mean, we are cribbing about changing certain small scale systems, and we are seeing that nobody wants to change, nobody wants to do the right thing, and then think about these people who made people believe that no, Earth is not the center of the universe. I mean, that was a huge change in a very religious age. So thank you for sharing everything that you said. I'm sure everyone who's watching has learned a lot. I personally had a wonderful time speaking to you. And to everyone watching, I would say, please come join our mastermind community. I keep saying that a community is something that will help you not just build your career, but it's like a confluence of all, like not just like-minded people, but people who are truly interested in learning about a certain topic. And in our case, it's called Space Careers Mastermind. So I'm going to put the link in below for you to come and join. And don't worry, I don't spam you with emails every day. Relax. I myself don't like this. I only talk about things that will help you understand space more, to understand which area you should go to, and then listen to experts talk about people who have done well in this field and how they have done it, and lots of other things, including the book club I mentioned. So I'm going to put the link below. I hope all of you are going to join and subscribe to this channel. We are going to come up with many more experts like Kshitij. And Kshitij, thanks a lot. It's been such a pleasure listening to you, talking to you, and I am going to look forward to everything you're going to do in your field. Thanks a lot.
Thank you so much for like connecting with me, and I was like very lucky enough to have these kind of discussions about all these journeys and all. So thank you for having me.
Oh, well, likewise. Thanks. Have a wonderful day and wish everyone a very, very nice weekend. Thank you.